Hello, ladies and gentlemen. Welcome to our webcast, iRobot's Journey to Product Nirvana. Today's presenters include Kevin Wrenn, Divisional Vice President and General Manager of PLM at PTC, and Steve Drzewiczewski, Senior Manager of Collaborative Applications at iRobot. My name is Nicola Vadikian, and I will be moderating today's webcast. I'll also be recording the webcast for replay purposes. You can submit questions at any time, and we will do the Q&A at the end of the webinar. Now, I'd like to introduce you to our first presenter, Kevin. Kevin, you may begin the presentation.
Nicole, thank you very much, and good afternoon or good evening to everyone. We really appreciate you showing up for today's webcast, and thank you in advance to Steve for being here and being able to take us through the iRobot story, which I think you'll find interesting and thought-provoking. Just to give you a sense of how it's going to go today, I'll give a bit of an introduction. Should take less than 10 minutes. The bulk of today's talk will be given by Steve, and then I will summarize things together at the end, and then also give you a chance to ask some Q&A. So along the way, if you come up with thoughts, ideas, or questions, we'd ask that you jot them down in advance of the Q&A period at the end. So that being said, let me just jump right in. So at PTC, in talking to our customers and doing research and listening to people, we see some major trends happening in product development. And some of the things I'd like to point out on this particular chart to you is, number one, on the far left, 40 out of the top 100 discrete manufacturers plan on offering product as a service. And if you don't know what that is, it's the Rolls-Royce model of power by the hour, where airlines don't actually buy the engine any longer, they just buy hours of the engine running. And many companies have kind of started to copy that business model. GE Aircraft Engines has done it, Trane Air Conditioning has done it, and as you can see, 40 out of the worldwide top 100 discrete manufacturers plan on doing that. And that obviously requires a different level of, let's say, digital everything, including digital engineering. The other number I'll point out on this chart is 70% of all discrete manufacturers will have a connected product in the market sometime in 2017. I know that the year's going by fast, but here we are in November, and so we're basically on the doorstep of 2017. So a trend that's hitting not only the most important discrete manufacturers in the world to the most sophisticated level, but also connected products are affecting the vast majority of product manufacturers out there. The underpinning idea here is this idea of digital thread, or some people say digital twin, others may say digital tapestry, but nonetheless, it's this idea of being able to begin a digital thread in the earliest thoughts of a product, starting in product development, having that go through manufacturing, out into service, continuing on into the customer's hands, and ultimately circling back to product manufacturers. And this idea of digital thread is such an important topic these days that even companies like McKinsey, who, to my recollection, haven't written a lot about product development in the last 25 years, are really on top of this subject. And so for us at PTC, we see this kind of fundamental change in the marketplace being the ability to connect to your product while it's in the customer's hands, but that fundamental difference is really offering a pretty profound change to how we have to think about digitally engineering our products. So to start thinking about that, let's just talk about digital engineering. This is our definition, that's the PTC definition, a digital representation of the product that's developed for connectivity, this idea of connecting to it in the customer's hands, that's developed for all downstream functions, inclusive of your entire value chain and inclusive of the customer itself. And this full digital representation is built to do interesting things like do connected service and connected manufacturing, do connected product performance feedback and traceability, use it for improved simulation, meaning remove boundary conditions and assumptions and replace that with actual real-world operating conditions. And then, of course, no question about it, as always, being able to create better, higher fidelity, more interesting deliverables up and down the value chain. And so that's how we think about digital engineering and its definition. The question I normally get when I give this talk to customers is, well, a fully digital representation. What is that? And our answer to that is it needs to be fit for purpose. So you could imagine if you were a light bulb manufacturer versus a CAT scan manufacturer, that you'd have a different fidelity of digital representation for the light bulb as you would for the CAT scan, although both of those could be connected to the internet. And so the rule of thumb here is create digital representations of things that will be used downstream. So if you think about mechanical parts, electrical parts, software parts, other things for traceability like functional models and requirements, etc., all of those could be part of the digital representation, or any subset of those could be part of the digital representation. So in the end, the digital engineering representation requires a bit of thinking. So with that kind of as a backdrop as digital engineering, what we've done at PTC is we've put together this idea of a digital engineering transformation. And the idea here is to offer some guidelines for our customers and partners to improve the way they think about digital engineering in the world of smart connected products. And it's organized in 3 bands. The bands are understand, advance, and outperform. And so just very simply here, in the understand band, it's the idea of taking data that you have access to today inside of your enterprise, whether that be in enterprise systems or in connected data to products that you may have in test beds, or even connected data that you have with products in the field, and make better use of that to make better decisions and make better products. And then in the advanced stage, it's to say, okay, let's now start to employ some thinking about designing for the connected world. So you see an outcome called design for connectivity there. And if you're going to do design for connectivity, you're going to need to think about traceability. And so if you're going to want to trace all the way back to requirements, you need to create traceability from requirements through a product structure out into the product in the field so that you can trace back to it. And if you have digital product traceability and design for connectivity, you can imagine that you will have designed some custom data streams for yourself to bring back data into your environment to do all kinds of interesting analysis on it, whether it be physics-based analysis, quality analysis, machine learning, or even big data analysis on it. So anyway, in the advanced stage, you're thinking about, let's say, advancing the state of your product. And in the outperform stage, really in summary, it's the idea of being able to modify the product while it's in the customer's hands. And so I won't give you a full, let's say, dissertation on the whole journey, but what I did want to do was give you a quick overview of the understand band, because that will be the basis of Steve's talk that I'll give you here in a couple of minutes. So 3 key concepts in the understand band. Of course, digital product definition. I talked about that a lot on a previous slide, so I won't talk about it here, but it's talking about being deliberate about what is in your digital product definition, starting likely with a CAD model, moving through a bill of materials structure, organizing and collaborating over that data inside of your enterprise, using all of that data. Second concept here is universal data access. So if you've created all kinds of rich data inside of product development, now it's the idea of making it usable downstream. And frankly, many of our customers tell us that really the only people that ever use product development data are the people that actually put it in a PLM system. And our objective here is to unleash that asset to the rest of the organization. And then the final idea here is performance-based analysis, and that's the ability to start to do what I talked about before, which is remove the idea of boundary conditions and assumptions from your analysis and actually move into the idea of using real-world operating conditions. So that's a bit of the summary. What I'd like to do now is ask Nicole for us to jump to a little bit of a couple of polling questions we have, just to kind of warm us up in front of Steve's talk.
Thank you, Kevin. To give you an understanding of where you and your peers are on the digital engineering journey, we have 2 poll questions for you to answer. The first poll question is, how consistently and accurately is your digital product defined across the organization? Extremely, very, moderately, slightly, or not at all? We're going to move on to the next question. How accessible is product data across your organization? Please rate. extremely, very, moderately, slightly, or not at all? We appreciate you taking the time to answer these questions, and we'll share the results at the end of the presentation. And now I'm very excited to introduce to you our featured presenter, Steve Drzewiczewski of iRobot. Steve has been with iRobot for 8 years and oversees the enterprise PLM implementation in addition to other collaboration tools. Prior to iRobot, Steve had 11 years experience as a PLM MCAD consultant. He's a University of Vermont graduate with a degree in mechanical engineering. All yours, Steve. Thank you.
Thank you, Nicole. Thank you, Kevin. I'm excited to be here today to share iRobot's PLM journey. Before I get started down our journey, let me tell you a little bit about iRobot for those of you who may not be familiar with our company. So iRobot is the global leader in home robotics. We have over 25 years experience helping people avoid dull and dirty tasks. Founded in 1990, we have over 500 employees located throughout the world, with our main headquarters located right here in Bedford, Massachusetts, outside of Boston. Back in 2002, iRobot created a successful and growing category called home robotics. Today we have more than 14 million home robots that have been sold worldwide, which are revolutionizing the way people clean both inside and outside of their house. So back in 2004, we began our journey down the PLM path. We had just been rewarded a large government contract that really required us to change the way we managed our enterprise data. Like many companies out there, we probably had several different systems to manage our different data depending on which division you were in or which CAD application you used. We had some commercially available products to some less than sophisticated solutions that I'm not so proud of. If iRobot was going to grow and be competitive, we needed to standardize on a single solution. That tool, at a minimum, needed to support multiple CAD systems. It needed to be able to support basic PLM concepts like revision control, role-based security. It needed to be configurable. We didn't need somebody to have to go in and program hundreds of lines of code just to make a simple change. We needed to have out-of-the-box processes like change management. It needed to be used easily across multiple departments, from our sophisticated and talented engineers to some of our less technical savvy people in the finance organization. As we were early on in our journey, our company was only 14 years old, we did not have a lot of sophisticated processes. We had no experience with a PLM tool. So when we started this implementation, we chose what we called the quick start approach. This was led by the PTC Global Services team. They came in and they leveraged out-of-the-box basic configurations of the tool for things such as life cycles and processes like promotion processes and change processes. At this point, our engineers knew how to manage CAD data in other systems, and that's really all they understood. So for the first few years, Windchill was primarily a glorified CAD vault. They checked in their data, they checked out their data. As our support team became more knowledgeable about the power of a Windchill, we realized there was more power to be unlocked. If iRobot adopted a part-centric approach, we could gain much more efficiencies in the way we did things. We quickly transitioned ourselves from a CAD-centric world to a part-centric world. And the Windchill part now was the center of the universe, which we connected not only CAD data to, but other information such as the drawings and important documents like articles of inspection, requirements, and test artifacts. After we had done all the data migration from our legacy systems, Windchill was now required to be used by all projects, and we mandated people use this part-centric approach. Any new projects must begin in Windchill, and they must use this approach. For engineers, though, there was definitely more work to do than had been done before. Prior to this, all they needed to worry about was saving their CAD models. So there was definitely more work for them to be done. After muscle memory was formed, they determined it was not so painful, but I don't believe they felt they got as much value as the rest of the organization did. Engineering received definitely some incremental value, but as we'll see in later slides, our operations teams received the bulk of that value. So in order for our implementation to be successful, we realized we needed our engineers to really want to manage their data in our systems. We had to find ways to give back more efficiencies to our engineers to make their jobs easier, since we were asking them to do more work than they had been asked to do before. In order for us to really give back to our engineers, we needed to implement solutions to make their lives better. But first, we needed to figure out where they had challenges, what was impeding their work. So we listened to our engineering teams. We also listened to our operations teams. How did they want to work in the tool? We initially started with a single approach of using a steering committee, but we quickly realized if we were going to adapt, we needed to modify our approach of gathering feedback. Initially, our steering committee was composed of 10 people, mostly managers and directors from across the organization, such as engineering, finance, and operations. What we did is we went in and we ranked the tickets that were in our system on which ones should be highest priority and which ones should be lowest. Well, as we found, though, most of the committee was so far removed from the day-to-day operations of the tools that their input was less effective. The rate of improvements that our team was able to achieve was slower than the frequency of our meetings, and pretty soon people got less than excited about going to another meeting to talk about something there where work did not feel like it was getting accomplished. So we looked at our meeting approach, we changed it slightly, and we came up with a new concept called the advisory board. We called it the WAP, the Windshield Advisory Board. Any cool meeting had to have a 3-letter acronym to get people to go to it. So we had a larger sampling of attendees. We had, again, our management representation, but we now brought in more of our power users. The Windshield team also provided updates on work that we had been working on in the past quarter. This allowed the advisory board to understand what progress we had made and where we were trending. We also informed them of any new upcoming functionality that was being released in later versions of Windchill. We still worked on prioritizing our large projects, but we also brought in things such as gamification, where instead of talking about every single project that was in the backlog, we let engineers and the people in the meeting vote on which topics they wanted to talk about. The top 5 vote getters would be discussed by the company. And then people would pitch why that project was important, not just to their department, but to iRobot. And very quickly what we saw is people switching from focusing on what was most important to them and what was most important to iRobot. As we were approaching one of our major upgrades, we also held another type of feedback session, which was an organization-wide open feedback session. We brought in a facilitator from outside of the Windchill team, from our business analysis team, to lead the session. This allowed us to be removed from being the leader of the session, and we could actively participate as members. We allowed people to talk about what was working, what was not working, and we were able to take that output and categorize it as, was it a functional issue? Was it something that didn't work with picks and clicks in the tool? Was it a process-related issue? Was it something that iRobot had created and we could possibly modify our process? Or was it a training and education issue? Was the tool working as designed, but people didn't know how to use this? As we were entering that big upgrade project, we took that body of work, we looked at all the functional issues and process-related issues, and compared that against the new improvements that were being released in this latest version of Windchill. And very quickly we realized we were able to knock off 40% of our functional requirements or functional issues just by the upgrades in the new version of Windchill. We were also able to modify some of the process-related issues as well. Anything that we were not able to address fed into our improvements backlog that would be addressed at a later date and time. After the upgrade, we again liked the different mechanisms, but the advisory board, again, it was still a little too bulky for our likings. And what we ended up moving down towards recently is departmental meetings. So now we get down to the actual competencies. And we'll meet with just groups of mechanical engineers, just groups of people in supply chain, just systems engineers. And what this allowed us to do is collect feedback from a similar group of people that were very familiar with one another, often remove the barriers of people being afraid to speak out and sounding stupid. They were all their coworkers they worked with daily, and identified a lot of common pain points and what we also considered to be quick wins, where for a small amount of investment on the Windchill support team's side, we could eliminate something that was very painful for these engineers. So we started tackling more of these quick wins to give back more to our engineers. As we were looking at the way we had previously done projects, up to this point, most of our projects were large IT-led projects which involved a project manager, a business analyst, and typically spanned anywhere from 9 months to a year and a half. While the projects themselves yielded great value to the company, if you weren't on the other end of that project, on the end receiving the value, for a year and a half, you would have to just sit there and struggle with any of the challenges that you had. So we tried to look and say, hey, can we do it just a bit of a different way? The hardest thing we had to do is convince engineers that can we give you a non-100% solution? Can we decompose your problem into smaller bodies of work where we give you a 60% solution after 2 months? 2 months later, we give you the 80% solution, and then another month later, we give you the final solution. By decomposing this project, it allowed us to balance out our work and give back value to different groups in the organization at a much quicker rate than the monolithic project approach we had attempted prior to that. So by doing this, we were able to give back to to not just our engineers but our operations teams, they also felt that they had been heard much more openly and readily by our team. Everyone felt that they had more ownership of our PLM implementation. So looking at this next slide, this takes us through the majority of the highlights of our PLM journey. So back in 2004, we started with our basic Windchill setup. And then all the way to the far right today where we have Windchill Product Analytics Cost. And throughout this journey, we've kept adding in additional functionality, some of which is out-of-the-box functionality, some are additional modules that we've purchased. The first piece here we look at is really our core implementation. This is started again back in 2004, where we set up our system with that quick start approach. We migrated all of our data in for our different data sources, and then we mandated that people use the system. In order for us to be effective, we had to have that top-down buy-in to make sure that all of our engineers use this system to store our data. Without engineering data, the operations data would be non-existent. One of the next things that we needed to do was transition our change process out of ERP and actually where our design data was being modified and maintained. So moving that from ERP to PLM was our next big implementation we did. After that, we started looking at where were some inefficiencies in the way our engineers were working. And we saw that every time an engineer was about to release a design, they went through, they modified and created a PDF of the drawing. They then later went and checked out that drawing, attached the PDF as an attachment to the file, and checked it back in. We saw there was some quick inefficiencies there that we could easily attack by solving this with the publishing capabilities in Windchill. We changed the publishing to automatically generate PDFs for the engineers, and now they quickly got back their time that they were giving to generating those PDFs. The next three topics really kind of span out of the mechanical world. The majority of our initial implementation focused on our mechanical engineers. While we did have some of the electrical engineering teams managing design data in Windchill, we didn't have their fully defined bills of material. We typically would have one part number representing the PCBA and a zip file containing the design data, but no representation on the number of components, the types of components, and things of that nature. As we were about to journey down the ECAD path, we, as most of my support team were mechanical engineers, learned quickly that electrical engineering was definitely different than mechanical engineering. They required different types of information to be able to drive their tools. One of the most important things we realized was parts classification. They needed to know whether it was a resistor or if it was a capacitor. Was it an IC? And they needed to be able to search based off of very specific design variables of those components to be able to select the right component. Do I need a 1K tolerance, a 1K resistor? Do I need a 2K resistor tolerance? Does it need to be 5% tolerance or 2% tolerance? We then moved into supplier management, which allowed us to not only capture who our suppliers were for the different parts, but whether or not they were an approved supplier, a preferred supplier, or somebody we should not be using at all. The last leg of this journey, once we had those two pieces set up, was ECAD data management using the Workgroup Manager. This allowed our engineers now to take manual processes we had defined through BOM import techniques to get bills of material into Windchill and automate that very similar to what our mechanical engineers had enjoyed with Creo and SolidWorks. So through the implementation of the ECAD Workgroup Manager, our ECAD people felt less like third-class citizens and much more like a first-class citizen. Now that we had our fully defined BOMs, we had electrical, mechanical, we also had things such as packaging, artwork, everything that we needed to produce a SKU inside of Windchill. We needed a way to get that data out of Windchill and to our contract manufacturers to quote. At iRobot, we don't manufacture any of our products. We have gone with an approach where everything will be outsourced to a contract manufacturer. So getting them these quoting packages was a very important piece that we needed to come up with an approach. The last two pieces here we're looking at is things our operations team was able to do. First, being able to forecast how many items they were going to use from a particular vendor or manufacturer in a given year. So they wanted to be able to forecast, I'm going to sell so many units of this particular SKU and another SKU, how many resistors am I going to be using? And where are those resistors coming from? By putting together a forecasting BOM, they were able to go in and very quickly build out a single level bill of material of all the SKUs that they were selling at a particular contract manufacturer with the estimated quantities. Then leveraging out-of-the-box reports in Windchill, they were able to do a multi-level component list and find out at an exact level how many 1K resistors they were going to consume this year, how many inductors they were going to use. And they can then also see which were our suppliers for those parts. And then could I go in and better manage my supplier negotiation process with data to go in and get better rates. The last piece on this journey is our implementation of the Windchill Product Analytics Cost Module, which allowed us to take and standardize how all of the cost data came in from our contract manufacturers when they quoted us a design, and how we actually could maintain that in one central repository to speed up the quoting process. When engineers were building out a new design, they could then get data back at a much quicker rate. So through this journey, there were 4 outcomes that I really want to break down into a little greater detail. The first, which I like to think of as our core PLM implementation, the bills of material, visualization, and change management. Second, our implementation of component and supplier management. Third, the ability to share our data with the supply chain. And lastly, a management of our cost data. So jumping into the core PLM, one of the things that we saw right away, even though our engineers weren't excited about some of the new work they had to do, they definitely had new capabilities that did not exist before. The one that I like to highlight right away is where used. Again, we had some systems such as Intralink that allowed us to do very basic where use capabilities. But as I had mentioned, we had some data stored in Intralink. There was some data stored on network drives, personal computers, and other systems that we shall not name right now. And it was very difficult from an organization level to find out where a component was truly used across our entire enterprise. Also, one of the things that pained me very greatly when I came to iRobot was the proliferation of Excel bombs. And what we were doing was managing bills of material in Excel. I like to call this Excel PLM. While a very flexible system, it was not a repeatable process. And trying to find where the source of truth was very difficult. That same copy of bill of material might be on 5 different users' computers with the same exact name, but different content within it. Eliminating Excel bombs was an absolute necessity that we had to do. Again, as I talked about in the very previous slide, we automated the ability to create PDFs, and just recently we also generate now step files for our part models as well. Again, taking away the tasks that operations would always come and find an engineer, try to find the right engineer to get that PDF or that step model generated for them. And of course, they typically would need it immediately. So the engineer would need to drop all of their work to go generate this one deliverable for that particular person. By removing that barrier, engineering was free to, again, focus on what we wanted them to do, which is build us the next generation of cool robots. And the last benefit we saw here with our engineering was really streamlining the engineering change process. When we were doing designs now, we were able to go in, if it was an electrical design, only select an electrical approver for their approval. If it was a mechanical electrical design, we could also bring in mechanical and electrical for approval. This would now no longer require additional people to come in and approve changes that were not relevant to their competency. Probably some of the biggest benefits that we saw was downstream. Our operations organization's use of Windchill over the past 12 years has grown exponentially. By unlocking the access to this data, again, no longer having to go run down the hall and find an engineer, not just find an engineer, find the right engineer, to get them the data they needed out of other systems, was an incredibly liberating thing for our operations team. We finally had a single source of truth, one system to go and find out where is our bill of material defined, how many of those resistors do we have on this PCBA. Through the change process, we brought the operations team into the processes earlier, so they were not only aware, but they could also help identify what the impact of that change was. Did we have inventory on hand that we need to go and factor in? Did we need to scrap this product? Could we rework it, or could we use it as is until we exhaust that stock? We also helped the operations team by extending access into our Windchill environment to our contract manufacturers. And so for our contract manufacturers, they would come in through VPN, and they would also receive notifications when changes were completed. So when that change got approved and was released, they no longer had to get a notification from the operations team. They got it directly from the system itself, and they could go in and review that change and get the data that they needed. The next big benefit that we saw was moving on to the component and supplier management. And in Windchill terms, this is PartsLink and Summa. So the first thing we needed to do is, again, get our electrical engineering component library up to snuff with what they had managed in previous tools like Excel and a MySQL database. And what we saw is they really needed part-level detail of resistor characteristics and the ability to search off of that. And they also needed this data directly inside of their CAD tool. Just putting the data inside Windchill was not going to be enough for them. So one of the things we did is we built a customization. We don't build a lot of them at iRobot, but we try to do it when there is a significant value. And what we found here is by putting essentially an electrical components library integration together, anytime a person created one of these electrical components, it automatically got sent over to this library for them. We can now keep our engineers directly in their CAD tool for a significant longer period of time, which allowed them to focus on their task, which was designing those next generation PCBAs. We also had increased search capabilities directly inside of Windchill with Parts Link Search. That allowed us to find parts at a much easier rate, and it prevented us from going in and duplicating parts. When we first went down this effort, we were astonished by how many duplicate 1K resistors that we were finding in our system. With supplier management, one of the other big benefits we saw, as we had, again, for an off-the-shelf part, we may have 5 manufacturers for a resistor, and there would be typically 5 data sheets. Prior to Sumo, we only would put a single data sheet in the system. We would either have to pick a generic data sheet that represented most closely all of the parts, or we would need to manually assemble a data sheet with the 5 different data sheets assembled to it. If we added 6 data manufacturer, we would then have to add another data sheet to that list. So by moving to supplier management, we could actually now attach a data sheet directly to the manufacturer's part. And this allowed our engineers to look directly at a specific manufacturer's data sheet. Was it the Panasonic resistor we were looking at, or the Vishay? And they could now see specifically which one they wanted to use in their design. From our operations, there was tremendous value received by this set of technology. The first being the ability to analyze our bills of material and see what was the breakdown of our electrical components. They could now get a classification output in their BOM reports and see how many components on the BOM were resistors, how many were capacitors. They also could look at the different suppliers we had on our systems and actually look and see, hey, how many of our components are going to Panasonic, how many are going to Vishay. This allowed us to have much better, more meaningful conversations with our suppliers. As I mentioned earlier, again, we use contract manufacturers, and it's not in a contract manufacturer's best interest to drive down the price of components, as they get paid typically on a percentage of the cost of the finished good. So for us, we would actually go in and now negotiate directly with those component suppliers to get better rates on the parts. Now that we actually could determine what the amount of components we were going to use, we could now spread that strategically across a couple strategic suppliers. Additionally, we could now, our operations team could go in and flag parts where we wanted to say this was a do not use part or this was a preferred component. We also were able to have a much more streamlined supplier introduction process, which included the ability to review our suppliers as they came in. Prior to this, a supplier was really just a free-form text field on a part attribute. So now we actually had a whole way to get a new supplier into our Windchill system. So now that we had that fully defined BOM, as we talked about, getting it out of Windchill would be the next challenge. So what we found is we had a process created called the VQP, the Vendor Quote Package, that one of our engineers came up with. And while it was effective, it was very time-consuming and it was very detail-required. So an engineer would spend sometimes up to 3 weeks gathering all the data out of Windchill, verifying that it was built correctly, and then handing that off to the operations team. So one of the new functionalities that came out at one point in Windchill was packages. Our team suggested, hey, why don't we look at replacing the VQP process with this functionality in Windchill? So as we started to investigate this, there was a lot of requirements that operations initially wanted because it's the way the VQP process did that. So as we worked with our contract manufacturers, we had to see how open they were to working with something that was out of the box and very easily generated from Windchill, or something that was highly customized and took a lot of manual effort. With several negotiations and discussions with our contract manufacturers, we were able to find what their right balance was. And we were able to finally be able to generate these packages purely by our operations department. They could go in and pick the top level SKU that they wanted to export or the change that they wanted to export and package that all up, get a zip file, and send that off to our contract manufacturers. One thing that we did realize we needed to change and build a minor customization is to emulate the way the VQP was structured. There was one folder in there that was all the drawing PDFs. A lot of our contract manufacturers did a lot of their quoting based on these PDFs. While the actual package did include them, the way to get to it was a little less than optimal. You would have to navigate to each drawing in the manifest and be able to go and navigate to its visualization file. We found this was not ideal, and we again put in together a small little customization that found all of those PDF files, put them in, extracted them out of the archives, and put it in one folder called Drawing PDFs. So now when the contract manufacturer opened up this package, they were able to quickly find all those drawing PDFs meant for quoting. And again, one of the big takeaways is our package process went down from weeks to minutes and maybe sometimes hours for more complex designs. This was a huge win, not only for engineering, who became significantly less involved in this process, but also operations, who was able to do this now at 9 p.m. at night and not have to find an engineer who may be working late. And the last thing that I want to talk about is our Windchill product analytics cost implementation. So prior to WPA, we had one person on our team that was responsible for managing all the cost quotes that came in from our contract manufacturers. And as you can imagine, there was a lot of back and forth between one design and another, and several spreadsheets that were stored. So we tried to find as ideal way as possible to store this cost data, but ultimately it ended up in several different Excel files. And if an engineer was starting a brand new design that was 85, even 90% of a previous design, it still took several weeks for her to be able to get us a cost breakdown analysis of that new design. As we found that this was not optimal, we wanted to look at, are there better ways of doing it? We found that WPA provided us a tool that allowed us to have one location where we could centrally manage all of our cost data. As a new design was being created, if it contained data that already existed in the tool, costs that had already been quoted out, we could give you a cost analysis significantly faster with only small gaps that had to be quoted from our factories. So our engineers now were given earlier access to this data. We actually took the data and presented it directly inside the Windchill bills of material. So now engineers had access to data that had been previously locked up by our operations team, similar to the challenge operations had earlier, where engineering had all of their data locked. Cost data was that one chip that operations kept from engineering. Through some very careful negotiations, we finally got that keys unlocked, and we now got that data in the engineer's hand. What we found was engineers now spent significantly less time wasting time on a design that would never have been feasible given their cost budget. Now that they could actually see three particular components that might meet the requirements, they could see what the costs were. Which one of those would actually fit within my cost budget? So engineers were happy to be able to focus on a part that was in their price range right from the start versus picking components that would definitely get the job done but not meet our cost targets. Our operations team that managed costs grew from one person up to now 4 people that's managing all of this cost data. And again, without having a tool like WPA, there would be no way for them to easily manage all of this data. Anytime that we're now about to do a cost down analysis and look at, hey, can we remove costs from an existing design? Prior to this, it felt like a lot of guesswork was being done. Hey, this feels like a part that is expensive. Let's try to redesign that. Now, out of WPA, we get very precise reports with Pareto analyses that show where the top 80% of the cost in that design is, and now we can go and look specifically at which parts we can target for a cost down effort versus guessing and trying to remove costs. And the last piece is the ability for operations to provide these detailed reports very quickly. Now, operations can do these in a matter of minutes for all the cost data that's already inside the system. When they get that new data back from our contract manufacturers, they load it into the tool, and again, very quickly they can provide high fidelity reports to our engineering team to make better decisions. All this, of course, allows us to make much better product decisions, reduce product costs, and really focus our engineers' time on what they want to do, which is, again, build cool robots. So in summary, I want to kind of look back at our journey. Some of the things that I found were very valuable is listening to our users. If the users are not talking to us, you've got to find a way to get them to start talking. Engineers will very often be uncomfortable talking with other human beings, we found, so we found very creative ways of finding to get them to talk. Pizza typically does the trick, but again, engaging them, getting their feedback, making them feel like this system is their system. If you can give back to those engineers, that builds the confidence. Again, it will foster that greater adoption. One of the other things that we found is a lot of times when we're introducing new techniques or new processes to our organization, especially if they're brand new to iRobot, trying to show the end-to-end entire process will typically get lost on people. We try now to break things down into what we call a proof of concept mode, where we show a small piece of functionality, allow them to react. A week later, take their feedback, incorporate it into our next proof of concept, and build on that. And over the next few weeks or months, show them the end-to-end process and allow them to understand it completely without trying to breeze through it in an hour-long presentation with PowerPoint and some magic. The last piece here is keep pitching. My favorite project I like to talk about here is WPA. I've pitched this project now for over 3 years to our different operation leaders. And while it was definitely the right project for us to do, it was not the right time. Operations had, unfortunately, many more important things to fire or to put out. And for us to now keep pitching that every year, while it felt very tiresome, and every year I kept going in expecting to get an answer of no, when they finally said yes, it was a very ecstatic moment for me that allowed us to give the operations team the tool that we knew they desperately needed. If we were to take WPA away from them now today, I think we would have a small revolt on our hands. So lastly, the most important thing we realize here is realize your journey one step at a time. This does not all have to be done at one foul swoop.
Steve, thank you very much. That was excellent, and I do want to compliment you on a few things. One is it was a great talk, very clear with, I think, some good depth. But you may know this, but I ran services here for many, many years, and I have to tell you that that is one of the most logical, quick win, value-focused approaches that I've seen in my years of watching implementations, and I've seen a lot of them. So thank you for that, and very, very impressive story, I would say. Now what I'd like to do is take you through the poll questions that I'm looking at for the first time with you. So here we are. So the first question was, how consistently and accurately is your digital product being defined across the organization? And you can see the spread. We have a bit of a bell curve here where we go from a few at extremely, some at very, almost half of all of us at about moderately, and then some slightly and not at all. As you can see from Steve's story, what they did was built their digital model a little bit at a time. And it was kind of needs-focused and value-focused. And from the value standpoint, one of the things I liked about the iRobot approach was this focus on operational value, which essentially gets sold inside of your organization, and then a focus on engineering value that gets engineers to actually accept and adopt the system. So on the engineering side, to streamline work, save them time to get the data they need to do, save them time in producing data for other people inside of the organization. And so the iRobot approach was to kind of move along from basic bill of materials, then to classify parts and do suppliers, then offer information to the supply chain, and then finally what Steve just spoke about, this idea of cost analytics. So keep in mind, the iRobot folks are using that principle of only creating digital data that's actually going to be used downstream. And so it's, for all of you folks that are at moderately or below, it's an interesting, I would say, point to take back to your implementation. Second question is, how accessible is the information across the organization? Interestingly, we have very, very similar shape with a tiny different bit of numbers. And so extremely, very, moderately, slightly, and not all, about 50% at moderately, and another 30% at slightly or not at all, and another 30% kind of above that, meaning kind of universal data access. That's actually, I would say, interesting input for us. So if you look at the thrust of Steve's pitch, it was really kind of centered on two outcomes on this digital engineering journey, let's say Wi-Fi icon, in digital product definition and in universal data access. That's why we asked those questions. And you can see that although those are two outcomes in a digital engineering journey that has 12 outcomes, there's enormous amounts of value there that can be driven not just in engineering, but throughout the entire supply chain. And so I think that the talk was extremely interesting and in line with, a broader digital engineering journey. I want to highlight just a couple of things from the PTC perspective. From a digital product definition standpoint, we're running over a little bit, so I won't give you a huge dissertation on this, but we feel like Windchill is the most complete PLM for all functions inside of companies that make connected things. It's the first smart, connected, complete, and flexible PLM on the market, and we look forward to helping you kind of advance your digital product definition with Windchill. The second thing I'd highlight here is Steve mentioned packages in communicating with their supply chain, which is an extremely effective way to communicate with the supply chain, as Steve talked about. We recently introduced, about a year ago, this idea of PTC Navigate, which gives a little bit, let's say, easier role-based access to data inside of Windchill. We can mash up that with data to third-party systems, and we see this as another way to advance not just communicating with the supply chain, but communicating with non-expert users inside of your enterprise. And so those are a couple of, let's say, interesting offerings from the PTC side that we would highlight. Before we jump to Q&A, I do want to emphasize the point that, as Steve mentioned, is you don't have to take this all at once. In fact, the entire journey that Steve talked about was kind of one step at a time. Do one step, add some value, move to the next step, add some value, move to the next step, add some value, which I think is probably one of the most practical, interesting, and best approaches that I've seen. Here's a few places that you could start, and we could help you start. Not by accident, it's organized in the way that Steve talked about it. First, BOM structure and reporting, parts classification and reuse, of course, change management, supplier management, and then sharing data up and down the value chain with Navigate or through some other means. If you see any of these as interesting, we'd encourage you to visit the URL shown here. So that being said, I'd like to thank Steve again before we move to Q&A, and I'd like to move to Q&A.
Awesome. Thank you, Kevin, and thank you, Steve. Now let's start to take some questions from our audience. Our first question is definitely for Steve. Steve, what does iRobot have planned next?
That's a great question. So, as we're looking at Windchill and a lot of our other systems, one of the big mantras in our IT shop is cloud first. So over the next year, we're going to be migrating ourselves from Windchill 10.1 to 11. And then towards the end of 2017, we're going to start our investigation into the cloud to migrate more of our infrastructure off to the cloud, I should say. Also, when we look at 11, we're going to look at things such as the Navigate. It's a great tool for our less power users that come in once a month to go in and get a PDF or get a drawing. Definitely some things that have piqued our team's interest as we've been seeing the different promotional materials from PTC. Again, one of the key things I thought about when we're looking at moving to the cloud is we have a team, counting myself, of 3 people in IT that support Windchill. So we have a system administrator. We also have an outsourced DBA, database administrator. We have a system analyst, and myself, who is probably only 20% nowadays on Windchill itself. So we also have a person directly inside of the business that helps a lot of our end users, and then there's a couple other people that support a lot of our Creo users and indirectly our Windchill users. So there's a handful of people, and my goal is to, again, get my core team off of supporting operating systems and maintaining servers and building functionality for our users. So the more that my team can get back out and meet the end users and talk about their challenges and opportunities and things that they want to improve on, the more value we'll be able to give back to iRobot. So probably the next year and a half is really more of an infrastructural development for us to, again, get us back into a better scalable platform. iRobot is expanding rapidly globally. We're expanding in China right now at a very drastic rate. And to be able to support that, we need to get stuff out of our Boston data center and into a cloud platform that's going to give our users much faster, better access to that data.
Thank you, Steve. Throughout your journey to consolidate more cross-functional processes and data in Windchill, Were there evolved legacy ERP versions of the processes you migrated to Windchill? If so, what were the challenges of getting people to migrate to Windchill?
That's a great question. So I believe there was several processes that lived in ERP. So ERP predated PLM, and initially that's where BOMs were managed, and that's where our changes were done. So that was probably the first piece that we moved from the ERP system to Windchill. And when we looked at the Windchill process, it was a pretty standard out-of-the-box workflow that worked for our basic needs. So we didn't have a lot of challenges of moving people there. Again, once we've put the process next to where the data was being managed, it made it relatively easily. I would say probably the one piece of functionality that we never quite got out of ERP was our design to order, or CTO, configure to order process. So that still lives inside of our ERP system, but it's no longer really a mainstay of our business, so it's something that we haven't fought to move.
Thank you. This may go along with the question that you just answered, but was there any integration with ERP systems such as SAP?
Yep. So back in 2010, we did integrate. We are an ERP Oracle EBS shop. We did integrate with our ERP system. It was probably one of the longest projects that we went on at iRobot. It was over a year and a half. It was a very complicated process because, again, PLM and ERP predated PLM, and there was a lot of data that was migrated over. So to get the two systems consistent, there was some inconsistent data in the way it was stored inside of ERP that we had to build some custom logic to handle. The main reason we were doing the ERP integration was to support our military business, where they needed to have all of the parts in the repair organization. So if they ever needed to repair any part of a robot that came in, they could actually see what that bill of material looked like. So we did implement our integration with ERP, but right now that's no longer a major focus of our implementation, as we no longer have a military business.
Thank you, Steve. The next question is, we have Windchill and we have Cadence for several years. How do we get help setting up to use the basic PLM via WGN? Is it more details of our situation?
That's a great question. So we use Altium as our electrical CAD tool, but again, I think for the most part the core tools work the same. We worked with PTC Global Services and a different PTC partner to understand what our needs were and figure out how to configure the workgroup manager. It definitely wasn't an easy task. We were one of the first customers using Altium to get onto the workgroup manager, so that made it very challenging. But after we were able to work directly with product management, we've seen great enhancements to streamline the process. But again, I think the key here is leveraging a consulting partner that has expertise in ECAD data management. It's definitely different than what most of the traditional VARs are used to, which is more MCAD data management. So it's definitely a different beast.
Can you explain the reasons you pitched for transitioning the change process from ERP into PLM?
Yeah, I think as I mentioned earlier, the key driver for me is that where the data is being modified and managed, you want to put the change process as close to that as possible. So since the majority of our data is now in Windchill, it made much more sense to have the change process in Windchill versus ERP. In addition, I think the other thing is PLM was significantly easier to modify the processes than it was for ERP. So I think that also gave us additional benefits as our support staff became more sophisticated. We could tailor those processes to meet our exact iRobot needs much quicker than we could the ERP processes.
Thank you. How are you managing the manufacturing data, MBOM, manufacturing process management, for your product build process?
That's a great question. I believe the majority of that is managed by our contract manufacturers and not iRobot.
Thank you. And I think we have time for maybe one or two more questions. How do you analyze PLM product data? What tools do you use and how effective is it to predict patterns for product improvement?
That is a great question that I do not have an answer to.
Absolutely no problem. What kinds of content did you associate with the bill of materials?
Sure. So, I mean, obviously the first part is the CAD data, the CAD parts, assemblies, and drawings. We've also brought in things such as test data, requirements documents, first articles of inspection, and things of that nature, that any type of document that was specific to a part, we tried to make sure it's associated to it so it was easily searchable and findable in Windchill.
Did you evaluate any other PLM platforms?
So this was before my time at iRobot, but there were several PLM vendors that they did evaluate. Some of our key requirements were the ability to manage multiple CAD software. So we are a majority of the time Pro Engineer, now Creo users. We do have some SolidWorks data, so we need to be able to manage both of those platforms. We need to be able to manage our ERP data, or have a connection to our ERP. And so when we started looking at the different vendors very quickly with the ability to manage the majority of our data, which was Creo, Windchill became a clear leader in that battle.
Awesome. Thank you, Steve. Ladies and gentlemen, we are now out of time. As I indicated earlier, this session was recorded, and we will email it to all registrants. I'd like to give a special thank you to Steve for coming out today to our headquarters to give a great presentation, and Kevin as well for this informative hour. Thank you to our audience for participating in today's session. We hope you found today's presentation valuable and will return for future webcasts. Thank you.